audible and you are able to give me the solution in the chat box? If you have solved, okay, can you give me the answer? I think somebody has given A. Okay, I have not seen. Okay, got it. So we say A minus is A, wrong. If you are saying your answer is set A, it is wrong. A comma B comma phi, it is also wrong. Only Prathamesh is correct who is saying B comma A comma C comma phi. So the answer of Prathamesh is correct. Okay. How come? I will discuss. Others are completely wrong. Okay. What do we mean by difference? We have to take all those elements which are exclusively present in left hand side set. At the same time, they must not be available in the right hand side set. If I do comparison, this element A is present here, so I cannot consider A in my final output. That is the reason why we are not taking A in final output. A is common. We have to take exclusive elements present in left hand side set. Those should not be shared with right hand side set. In right hand side set, I am having two elements A comma C. Out of that, this small a, it's common. So we are discarding that small a. Do I have B in right hand side set? No. Do I have AC together? Together? No. So I am taking AC. Do I have phi here? No. So this will be my answer. B comma A comma C comma. I hope this is clear. Those who are saying A comma B comma phi, or those who are saying set A itself is the answer. Is it clear how it comes to be B comma A comma C comma phi? Do you have still doubt? I am there to resolve if the doubt persists. Is clear? In the difference, we have to look for only those elements in the left hand side set of the difference operator which are exclusively means those are not shared with any elements of the right hand side set. So I cannot have A because A is shared small a. I am discarding it. So additional elements are B comma A comma C comma phi. Okay. Moving further. What is the answer for what is the answer for this? Any answers? Okay. Yeah, Viraj has given 5. Recognition is also given 5. Absolutely correct. 5. As a null set. Why null set? In this set, I am having a pair A comma C minus A. Do I have this A comma C common with A? Yes. So what is left after removing this common element? I am left with nothing. That is 5. So 5 is my answer. Is it 5? Is it fine? Why the 5 is the answer? It should be fine. Okay. Moving further. What is the answer for C? A minus A comma B. A minus A comma B. A comma B together. Okay. So answer will be A. Correct. Now I think you are finding it interesting. Very good. What is the answer for fourth one? See the difference. Okay. Here we have taken A comma C as a single element. Here there are two elements. First element is A and second element is C. There exists a difference between problem B and problem D. So that you should remember. I am talking now about what is the answer for D. Can you give me the answer for D? Indeed, it is C. Yes, it is C. So such problems are frequently asked in your university exams. And if we are taking so much of practice, there should not be any confusion in scoring okay, highest marks in discrete mathematics out of, I will say. What is the answer for A minus P of A? As you are beginners, okay, for these sort of problems, I would suggest you to first write P of A and thereafter do A minus P of A. Otherwise, you would have confusion in your answers. Okay, if you are not computing P of A and directly doing the things. Suggestion is go for computing P of A. So how many elements do I have in P of A? There are 4 elements in original set. So I am going to have total how many in P of A? I am going to have total 16 elements in power set of A. Okay. So I think somebody has given the answer. Prathamesh is saying answer should be A comma B comma 5. I think the answer is wrong somewhere. Okay? A comma B comma 5. So let us do step by step. Even though you have solved, okay, just solve along with me. Nothing else. Okay, along with me. So just to make it clear, okay, let me write this as this. This is nothing other than null set. So the very first set is null set itself. So let me write it as 5, comma, next is A, comma, next is B, comma, next is A comma C. See how I am putting A comma C. It should be put as an element inside a set because power set is set of all possible subsets of given set. Okay, I'm putting like this. So I have taken for 5, then I should say see this one. This thing is altogether different from this. This phi is using the property empty set is subset of every other set, and this is for element phi. So I am making a subset using element phi. Okay. Further to this, com. Now we have to make pairs. So first pair will be. So where do I write? I have to write for total 16, isn't it? So I will say A comma B. Next, I will make pair of A with A comma C. See how I am making pairs and forming the sets. This is also very important. Okay. Next, I will make a pair of A with this. Okay. Next, I will make a pair of now B with B comma C. Now I will make a pair of B with I. Whether it is making a sense, it should make a sense. Okay. Now two pairs are over. Okay, I think yeah. We are left with one more pair. So A comma C comma 5 comma A comma B comma C comma 5 B comma B comma C comma 5 comma set A itself. So let me check whether these are the 16 elements available with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Two more are remaining. Okay, so can you tell me which two are remaining? We need total 16 subsets. Which are remaining? Which pair is remaining? That I have not considered. Can you tell me? I think I have taken first is 5. Okay, no problem. I have taken A separate, B separate. Then I am taking AC separate. Thereafter I am taking that 5 separate. Thereafter I am taking A comma B together. Then I am taking A comma AC together. Then I am taking A comma 5 together. B comma AC. Then I have taken B comma 5. Then I am pairing AC with 5. Then I have paired, what should I say, A with AC with 5. Yeah. I got it. Okay, can you tell me which is remaining? Yes, Viraj has answered me. Okay, very nice. Very nice. So that one is A comma E comma 5. This one, and other one is A comma B comma 5. I have written okay, and A comma B comma AC. Okay, have I written A comma B comma AC anywhere? No. A comma B comma A comma, and finally after this I am having set A. And let us check now whether these are the total 16 elements with us. Okay. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So these are your subsets present in power set. Now what is the question? The question is finding out A minus P of A. Okay. A minus P of A. What do you mean by difference? Only those elements which are available exclusively in A, but at the same time they must not be present in P of A. So do I have A as single A? Okay, single A present anywhere in power set. This A and this A are totally different. This is the point where students are getting confused. I am writing A inside a curly bracket, that is definitely having a different meaning. Uh, okay, if we are writing A, this becomes an element. A is element. Here, what is the element? Element is A inside a curly bracket. Do I have A anywhere here? No. So can I take that A? A will be present. A will be present. Viraj, how A is coming? Next, I will have B. Next, I will have A, comma. So this will be my answer. Now I want okay replies from all of you certainly. Okay, whether my answer is correct or incorrect, and wherever you require a justification. I have given you the answer. Only the 5 will not come. Otherwise, everything other than 5 will come. This is the answer. A minus P of. Just think over it. Let me know whether it is clear at your end. Does it make a sense? Whether it is too much complicated or too much simple? Complicated. Pranav is saying complicated. It is too much simple, okay, not complicated at all. Only the thing is you need to follow the instructions and laws which we were discussing at the start of set theory. We have started from Monday. Okay? Those laws we are applying, nothing else. What is A? A is A comma B comma AC comma 5. What is P of A in front of you? So if I say A minus P of A, I am going to compare every element of A with P of A. If match is found, I will not take that particular element. So I am starting with small a. Whether small a is present in P of A, anywhere small a. The small a and a small a with curly braces is different. This is a set, while this one is element. You cannot say a match is found. Okay? So if it is not matching, we are taking A as it is. So in the case for P, do I have B as an element which is present in P of A? No, I am not finding B anywhere as an element. I am finding B as a subset in P of A, which are different. So I have again taken B as it is. A comma C as an element. Do I have A comma C as an element anywhere? No, again no. So we are taking A comma C as it is. Next. Okay. And now just let me make here 5. One more. Okay. Phi or null set, both are set. Phi as an element. Do we have phi as an element present in P of A? Yes, we have phi as an element present in P of A. Hence, we will not consider phi in our answer of A minus P of. Is it clear? Which step is not clear? If it is not clear, okay, can you tell me which step is not clear? I want answers from all. Okay, I am thinking of you are not getting. Okay. Okay. If it is clear, okay, fine. 4 people have given 4, 5, 6, 7. Okay. If it is clear. Okay. Okay. No problem. Yes, I understood that. You have understood. Okay. Let us go further. So the answer for this, we have written A comma B comma A comma C. Okay. Further to this, what is the answer for F? A minus A. A minus A. Fine. Empty set because A is present in A. What is the answer for this? D. Okay, F answer for F is 5. Okay, I have written 5. What is the answer for G? B comma AC comma 5. B comma is comma 5. We need to only skip A. Okay, fine. Okay, fine, perfect. What is the answer for A minus 5? A minus 5. A minus 5. Answer is A. Using property directly. Okay, you should not again check. A minus 5 will be A itself. We are having property. If we are subtracting a null set from any other set, we are going to get the original set as the answer because pi doesn't have any element as such. Okay, what is the answer for I? It's answer 5. Okay, you are saying answer for I is 5. Yes, if you are subtracting anything from again, it will be 5. Perfect. Last one. A comma B comma 5 minus A. What is the answer for J? Answer for J. I am asking answer for J. A comma B comma 5. What is the answer? 5 itself? 5. Okay, 5 itself. Because we are having 5 as well, A as well, and B as well present in original state. Okay, very nice. We are having 5 as the answer. Good. Interesting. Okay. So I think there is vast practice of finding a difference, and any one of you should not lose a single mark whenever such question comes anywhere in either your GATE examination or university examination. Lot of practice I have taken. Okay. Now I will just ask, have you solved this one? A intersection B bar. Okay, sir, but in H, phi is present in E. Right? In H, A minus phi. Let me make it clear, Abhishek. You are having confusion in H, isn't it? What is your set A? This is your set A, isn't it? Fine. What is the meaning of this? I am writing phi means this one, isn't it? Minus this one. A minus phi. Okay. So what will be answer of this? A minus phi. We have to look for all those elements which are exclusively present in A, but at the same time they should not be available in set B. Okay. Set B, I am saying set B. So your set B has how many elements? Do we have any elements present in set B? Try to understand the difference. Okay. There is nothing inside the curly bracket on the right hand side. So how I am going to compare any element of left hand side with the right hand side? This is acting as an element inside a set and this is empty set. There exists a difference. Okay, if it was a case like that, this, if they have mentioned like this, after the last, okay, if this was mentioned, then you would have removed phi from your answer. But it is clearly mentioned that phi means empty set. If you are writing phi inside a curly bracket, then it becomes an element inside set. Is it fine? It should be fine, no? Still, if you are having doubt, let me. Do you have still doubt? Okay. Let me resolve the doubts, if any. Uh, let us. Okay, based on this, I have thought of one example. This is not pre-planned. So let set P denote phi. Let set Q denote phi. Let set R denote phi, comma phi. task is, let me know how many elements are present in original set and what are the elements present in power set of respective sets. Can you tell me the answers one by one? I am interested in knowing the cardinality value of each set. I am interested in knowing the number of elements present in power set of every set. Can you tell me? Yes? Yes? I hope I am clear. If I am clear, okay. Pranav Mahamuni is saying cardinality of P is 0. Fine, Pranav, correct. Cardinality of P is 0. Okay. What is the cardinality of Q? Cardinality of Q is 1. Would you say that cardinality of Q is 0? No, because we are observing that phi has one element in Q. What is the cardinality of R? Suraj is saying cardinality of Q is 2. How come? How cardinality of Q is 2? First of all, I am asking cardinality of individual sets. Thereafter, we will see what are the cardinality values of their power sets. So, power set of P. How many elements do I have? I have a formula 2 raised to n for n different elements in original set. So, how many elements do I have in set P? I am having 0 element. So, I will have 1 element in the power set of P. What is that element present in power set of P? That element present in power set of P will be phi. Are you getting? This is inside a power set because this is acting as a subset of. So how many elements do we have in power set of Q? That will be 2 raised to 1, which is 2. So now, please be careful. Okay, I have to have 2 elements now. What are those elements? Are you getting how this 5 comma 5 comes here? How phi comma phi is coming in power set of Q? Are you getting this point? Yes. So this is confusing, no? That is the reason why I have taken this example. Okay. Now let us go for next. I want P of R. So how many elements will I have in power set of R? So it will be 2 to the power 2. That means I want 4 elements in the power set of R. Yes. So let us write now those elements. So first one is phi. Empty set is a subset of every other set. Next, phi as an element. Next, phi as an element. Next, set itself. Every set is a subset of itself. Are you getting the difference? How the 4 are coming? So we have first written this phi. This phi is different. This phi is the null set, because null set is a subset of R. Then this phi is, we are taking one element from R and making a subset. This phi is, we are taking other element with the curly braces from R and making other subset, and thereafter we are taking them together, that is representing original set. So these are the 4 subsets of set R. That is the reason why my power set of R is having 4 elements. Is it fine? Does it make a sense? Now whether you have understood, whether there will be still any problem if anyone gives you any example. Are you going to confuse or you are going to solve it neatly and smoothly? I think you will be able to solve it. There will not be any problem. There should not be. So again a question. Whether you are able to solve this example yesterday. Which one? This D1. Okay. A intersection B bar union A bar intersection B union A bar intersection B bar is equal to negation A union negation B. How many of you have solved? Have you solved? Tried but not got. So the message is tried but not got. Abhishek has said he has solved. Okay. So shall we have solution of Abhishek shared over the screen? Abhishek, would you like to share your solution? Abhishek Bhor, would you share? Tried but not got. Not got means you are not following the laws. That is the reason why you are not. Sir, I will tell the steps. Okay, it will take a time. Okay, no issue. You can tell the steps. I will solve it so that everyone will understand. Okay, so we have to prove this. So we are going to start with the LHS. What is LHS? This one. I will copy down LHS. Okay. This is further equal to. I have to convert it to A bar union B bar. This is further equal to. Yes. Step number one. What to do? Yes, yes, yes. Tell me the steps. This is very crucial example. Ask for 4 marks every time. Take common from where? Okay, from there. So I should keep this as it is. That you want to say A T. So he's saying I should take it as it is, and we are observing union symbol. So he's saying I should take common. Common what? Union in bracket. You are observing it is negation. Sorry, A bar intersection B, A bar intersection B bar. So he is trying to say that I should take a common. Common what? I should take common. He is saying negation A. Okay. In bracket, what to write? If I take negation A as common, distributive law. Yeah, distributive law. Correct, Punika. Let us go step by step, so that the things will be clear and there will not be any confusion as such. Okay. So I am just adding one bracket for more understanding, nothing else. Negation B, negation again. This one is union, B, intersection, negation. I have done nothing. I have simply added one bracket just to make it more simpler. Okay. Further to this, let us keep it as it is. A intersection negation of B union square bracket. Now, what is our distributive law? What is our distributive law? Do you remember distributive law? Let me write distributive law over here. Distributive law A union. I have to take union outside, isn't it? So distributive law for intersection 90 degree. B union C is equal to A intersection B union A intersection C. Do we have such a distributive law with us? A intersection B union C is equal to A intersection B union A intersection C. So do we observe this as a right hand side of something? Do we observe this as a right hand side of something? Yes, I think I can observe, because assume this as A, assume this as B, and assume this as C. If you observe, then using this distributive law, you can write over here A bar intersection in bracket B union B bar. Whether this step is clear, I will say using distributive law. using distribute. Every time they will not provide you LHS and ask you to write RHS. Sometimes you can write in reverse way. RHS is given, we are writing LHS. Okay, if it is clear. So this is for the equal. Let me keep this as it is A intersection B bar union A bar intersection. What is B union B bar? What is B union B bar? Universal set U. Very nice. The law that we have seen yesterday. Okay. This is for the equal to. This is for the equal to. Okay. What is negation of A? Sorry, A bar intersection universal set U. I am asking this. What is A bar intersection U? A bar. Wow. This is A intersection negation B union complement of A. Is it fine? Is it fine? Is it fine? He is asking to join. Okay. Is it fine? Okay. Hope it is fine. I'm not writing everywhere. Okay. The laws you are supposed to write the law. Which law you have used? Equal to. Further to this. This A union A bar intersection comes outside. Again, I am making use of distributive law. B bar union A bar. Again, using distributive law. Union is inside, intersection is outside. Fine. This is for the equal to. What is A union A bar? U. Okay. Intersection. What is B bar union A bar? I do not know. Because I don't know the values of B and E. I don't know. I will keep it as it is. Further to this, what is universal set U intersection B bar union A bar? This is RHS. I think now this is clear. Have you got your answer? It is that much simple. Only you need to think logically. That is the reason why we have taken the logic and prepositions as the first chapter. I am trying to build the logic in you so that you will be able to solve each and every problem. If it is clear. If it is clear, take the snapshot of this example properly. Okay. Do not rely on this notepad files or snapshots. I would suggest you to write all the solutions in proper notebook. Once the lecture finishes or side by side, you can continue writing in your notebook. Randomly, I am going to make a call to a particular student and I will ask you to show your notebook with solutions. So on any day. So you should be ready. Any doubts up to this point? Anywhere? No. No. Then the question will be like this. Okay, next question. Sometimes in examination, theory exam, they will write prove using Venn diagram. So you know what is Venn diagram. It's a pictorial representation of sets. Sets are represented using circles and universal set U is represented using a rectangle. So if the question is like this, you can take these in your notebook or you can take a snapshot of this. You have to solve in your notebook. This is your first question. And second question to this. A intersection B intersection C is equal to A minus minus B union A minus. So how to prove using Venn diagram? We will be drawing a Venn diagram for left hand side. We will shade the part according to the operations mentioned. Okay. We will again redraw the separate Venn diagram for RHS. We have to again shade the mentioned areas using the operations, and we have to show both the shaded regions of LHS and RHS are matching. If that is the case, you will say that LHS is equal to RHS using Venn diagram. Is it fine? How to prove? I have to show you. Okay, how can I show that? How here? Just give me a second. If it is possible for me, I will definitely show. But it becomes. There is my. So how to prove? You are going to have a Venn diagram for LHS. If it is expected to prove like how A minus B is equal to, I am showing you for A minus B is equal to A intersection B bar. What is A minus B? I will have two sets. Out of that, I am going to shade the area which is exclusively present in set E. This will represent A minus B. Let us say this is set A, entire thing. This is set B, and this is set U, universals. So I have constructed a Venn diagram for LHS. In the similar manner, I will construct a Venn diagram for RHS. I will again have two circles over there. Draw it as a circle. Okay, on computer I'm using slides, so it may not be possible to have perfect circle. But while drawing in your notebook or in examination, you are going to draw it smooth. So this is A, this is B. I have to show A intersection B bar. So what is present in B bar? If this is set B, this one is set A, and I want to show A intersection B bar. Okay. Whatever is present here in set A, apart from this shared region, okay, this one I will have. In a B bar, I am going to have everything in B bar. Okay, let us say these are the contents of B bar. These are the contents of B bar. Out of that, these will also be a contents of B bar. Whatever elements which are not present in B, but those are available in U. I am now taking intersection of contents from A with contents from B bar. So I will again have this particular shaded region, this one exclusively, okay, other than intersection part. This will be present in A intersection B complement B bar. So this is my LHS, this is my RHS. Both the shaded regions are one and the same. Thus proved using Venn diagram. Is it fine? Will you be able to do it for these two examples? You have to draw the Venn diagrams and check the shaded regions. Is it fine? Okay. If it is fine, let us move ahead for a couple of questions for you. Okay. So these are the questions for you. If sets A and B are disjoint, let me tell you what do you mean by disjoint set. Disjoint sets are the sets which do not share anything. The intersection between the two sets is phi, a null set, then the sets are said to be disjoint. If sets A and B are disjoint, then which of the following statements is true? Replies in chat window. I am expecting it. Okay. Answer is A, all are saying. Okay. Answer is A. So I think shown you somewhere the answer as well. Okay. So if the sets are disjoint, that means if they are not sharing anything, A will not share anything with B, so I will have A as an output. In the similar manner, B will not share anything with A, so I will have B as an output if I take a difference of both. So you are going to have it as answer. Then they do not have a common element, so A minus B equal to A and B minus A is also equal to B. Okay. Next question, if A and B are disjoint, again they are not sharing anything, then which of the following statement is true? About the cardinalities. Take your time and let me know the answer. Again A for second. Okay. People are saying answer is A for second. Okay. So let me check. Yes, option is A. If A and B are disjoint sets, then their intersection is going to be phi. So while computing symmetry difference, what is the formula? We are taking union of two sets and we are subtracting intersection. Obviously, we are going to have cardinality of A union B exactly equal with cardinality of symmetry difference between two sets. Hence, the answer is for this as well as for this. Okay. Moving further. Okay, those who are having doubts in this and those who want slides, I will be sharing everything on the Google Classroom in the due course of time. Okay, next. Can you tell me the answer for this? If A1, set A1 is 1, 2, A2 is 2, 3, A3 is 1, 2, 3, 6, what is the value of intersection of all the three sets? Two common in all, Viraj. First of all, try to infer the meaning of this notation. This is intersection for A of I value varying from 1 to 3. So how to read it? This is nothing other than A1 intersection A2 intersection A3. You have to take intersection of all the three sets. It is in shortcut route. So which is the element which is common in all three? I will have 2 as a common in all. So obviously my answer will be 2. Let's check if it has to be. Yes. How about fourth one? If A equal to alpha comma beta and B equal to 1 comma 2 comma 3, what is the value of A cross B intersection B cross A? Absolutely fine. Okay, you should not compute what is A cross B and B cross A. Those who are computing, for them, my answer is you will directly select the answer phi. Why? Because we know that cross operator Cartesian product is not commutative. So anywhere, irrespective of elements in set A, we will always have A cross B not equal to B cross A. Thus, they will not share any element in common, and our answer has to be phi always. Okay? Why the answer is phi always? The elements ordered pairs of A cross B start with alpha or beta, and B cross A start with this. So they don't have any elements in common as such. So the answer is B. Is it fine? Is it fine? Oh. Let's move ahead. So next is this complement operation can also be represented in terms of universal set that I have already told you. The complement of set A written as A raised to C as well. This is new term. Okay, I said you can write it like this. You are writing a set name. You are putting a bar. This is one thing. You can write it like A raised to C as well, or you may write negation of A as well to denote a complement of C. It is the set consisting of everything not in C. What is the Venn diagram? It's a diagram constructed with a collection of circles drawn on the plane and having a rectangle representing a universal set. The circles represent the sets. Any values belonging to more than one set will be placed in the sections where the circles overlap. So you are observing a Venn diagram involving three sets A, B, C. If I am observing the intersection of A and B, it will be denoted using A intersection. If I am observing intersection of all the three sets together, I will represent it like A intersection B intersection C. Common elements in all the three sets. This one A intersection C. Which part? This part. Okay. And this one B intersection C. These are the elements present in the Venn diagram. This is very crucial to know. Okay. So I think uh, do we have time today? So shall I continue with the next lecture? Or do you have next lecture scheduled? Shall I continue? Or you want to go for next lecture? Which is your next lecture? Whether it is going to happen? Reply in the chat window. Do you have next lecture? Okay, yes, you are saying you are having next lecture. Okay. 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 It is 12:20. I have to start with new point, which is again very important. So what we will do? I will start with next point during the next class on Monday. Till the time you can study the concepts and solve the problems from Kenneth Rosen book. Okay. Let me show you. Don't close it. Okay. I will show you which problems to solve as a homework. Take it as a homework, and you can again send me solutions on my WhatsApp. Okay, what to solve that I will discuss. But where is that book? Kenneth Rosen. Yes, I do have. Okay, so let me show you what to do. Before we finish for today, it is opening. Till the time it opens, okay. Can you tell me which part you have not understood out of all the sessions that we had in this set here so far? So, is there any part which you have not understood? You can freely discuss till the time it starts. Make it wider. And let me directly jump back to that particular sets operations. Oh, let me close it. Let me make it bigger. Okay. So what to do? Yeah, we are here. So it is expected that okay, you will be taking this as a homework. Homework on page number 131 of this PDF. Exercise 1. Which examples to solve? Just note down. You'll be solving example number 1, example number 3, 1, 3, 5, 7, 9. Okay, I think total 51 questions have been given. Out of this, you can solve any 20 questions out of 51. Okay? I'm not giving any specific. So out of 51, total 51 questions, you can solve any 20 questions and you can show me the answers. This is a homework, not a assignment. Some points might not be covered, so you can skip those points. For example, here in question number 3, they are asking which of the intervals 0, 5, 0, 5, and this like contains this. So this is not covered. So you can easily skip this 3. Question number 4 is also not within the scope of our syllabus. So those questions which are not in the scope of syllabus, you can simply skip. But I would suggest you to solve minimum 20 examples from this page number 131 and 132 up to 130. Is it fine? Is it fine? Will you be able to solve at least first 20? Can you reply in chat box? Not first 20. Okay, any 20 out of the 51. Will you solve? Okay. And those who are curious for further, okay, for them, those who are curious for further advancements, for them, okay, hold on. I'm observing that you are not seeing this book and you are only relying on my lectures. It is perfectly fine, but this book will help you to build more and more, nothing else. Okay, that's fine. So, those who are curious for the further studies, they can go for 144, page number 144. This is option. Is it fine? Okay. Now you can simply switch on your videos. Switch on your videos for a while. Yes. Raj. Gaikwad. Okay. Who else? Abhishek. What? Oh. Let us see all of you. Okay. Let me see. If it is possible, turn it off. No problem at all. Who else? Uh, Anybody else? Okay. Who is else? Anuraj. Okay. Then anyone else? Okay. Mahesh Kangur. Yes. Pranav, have you turned it on? Why I'm not seeing you? Okay. Okay. That's all for today. We will conclude for today's session. You can continue with your next sessions. Thank you. Have a good day.